Okay, in this video we're going to look at a bunch of examples from like an elementary statistics class, and I'm not going to go through the background of the examples. We're just going to do the examples and introduce the concepts as needed. So the first thing that we want to do is make a frequency table with the following data. So notice we have 1, 2, 3, 4, 5, 6, 7, 8, 9 data points ranging from 3 to 21. And so you can make a lot of different frequency tables depending on what's called the class width. So let's go ahead and do one with a class width of 10 and see how that goes. So here's what we'll do. So here we'll have our data values here, and then the frequency of those data values in this column. And so this will be the frequency table. So let's say the data values that we want in this first entry will be 0 through 9. And then this second entry will be 10 through 19. And then in this third entry, we'll do 20 through 29. But notice that's enough because we end at 21. Okay, so notice that 0 through 9, we have these numbers, 3, 5, and 9, so that there are 3 members of our data set that are between 0 and 9. So that has a frequency of 3, that data range. And then 10 through 19, so this is going to be 1, 2, 3, 4. So that's our frequency for that data range. And then finally 20 through 29, so that's going to be 2 again. Okay, good. So let's maybe really quick fit in here something with a class width of 5. And so that means our data is going to be more finely split up. So let's say we do 0 through 5. Sorry, that would be 6 values. So 0 through 4, and then we'll do 5 to 9, and then 10 through 14, and then what do we need? 15 to 19, and then finally 20 to 24. Okay, so notice 0 through 4, we have 1 value, just the number 3. And then 5 to 9, we have 2 values, which is 5 and 9. And then 10 to 14, notice that's going to be 1 value, the number 12. 15 to 19, we're going to have 3 values, 15, 16, and 19. And then 20 to 24, we're going to have 2 values. So that's our frequency in this case. Now, we could increase the class width, but notice that's going to push a lot of things together and we're going to lose something about the data set. Or we could decrease the class width. Notice if we decrease it all the way down to 1, then we just recover the data set itself. So it's a really fine line depending on exactly how you want to choose this class width. Okay, so for our next example, we'll take this frequency chart and then answer 2 questions looking at it. So the first one will be how many data points are in this frequency, are in this study, and then what percent have a value of 2. So let's see how we can read this. We read this as a graphical version of this frequency table. So the data value of 0 occurs 5 times. The data value of 1 occurs 7 times. The data value of 2 occurs 10 times. The data value of 3 occurs 5 times. So if we were to write this down as a set, we would have something like this. 0, 0, 0, 0, 0. So 5 zeros, and then 7 ones, and then 10 twos, and so on and so forth. Okay, great. So how many data points are there? Well, here we can just add up how many of each type. So there's going to be 5 zeros plus 7 ones plus 10 twos, and then finally plus 5 threes. So notice that's going to give us 27 total data points. Great. And then the next thing we want to do is find what percent have a value of 2. Well, let's notice that we have 10 with a value of 2. So the total number with a value of 2 is 10 over the total number of in the sample, which is 27. So if you convert that to a percent, then that will give you the value that you're looking for. So I'm going to clean up the board and we'll look at a few more, and we'll look at more examples. So let's see at our next couple of examples. So here we have a chart that on the horizontal axis, it gives you the score like on an exam, and then on the vertical axis, it gives you the percent of a certain class that got a certain score on an exam. So the way to read this is that 30% of the class scored an A on the exam, 40% of the class scored a B, another 20% scored a C, and then finally 10% scored a D. So the question that we want to answer is, if 20 students are in the class, and so 20 students took the exam, how many scored a B? Okay, so we can answer that in the following way. We can take those 20 total students in the class and multiply it by the percent that scored a B, because we know what percent scored a B. That's going to be 0.4. So in other words, we're finding 40% of 20, but notice that is going to be 8. So that means 8 students scored a B. Okay, great. So the next one we want to look at is this pie chart. So if you spend $2,000 in a month, how much is for bills, given that your budget is broken down in the following way? So bills take up 35% of your budget, food is 20% of your budget, and then everything else is 40% of your budget. So maybe bills includes like rent and your phone and all of that kind of stuff. So we can do that the same way that we did this one, except students are replaced with this total money spent per month. And so what we need to do is find 35% of this $2,000. And that's not too hard to show, but that's going to be $700. So that's how much you spend on bills every month. Okay, I'll clean up the board and then we'll keep going. Okay, now we're ready for our next two examples. So let's say we have the following chart. And so this gives you the frequency of values within a certain range. So again, this is a graphical interpretation of a frequency table. So here we have between the range of 0 to 4, we have 1 point in the data set. Between 4 to 8, we have 3 points in the data set. Between 8 and 12, we have 2 points in the data set. Between 12 and 16, we have 4. And between 16 and 20, we have 1 again. Okay, great. So the first thing to answer is, looking at this chart, what's the class width? And remember, that's how you break your data down. And notice the class width is going to be 4, because all of these ranges are ranges of 4. And so we can just say the class width here is 4. And then what's the sample size? Well, what we'll do is we'll look at the frequency in each data set, and that will give us a tool to calculate this sample size. So notice there's one portion of the data set between 0 and 4. There are 3 members of the data set between 4 and 8. There are 2 between 8 and 12. There are 4 between 12 and 16. And finally, there is 1 between 16 and 20. So the sample size here is 1 plus 3 is 4, plus 2 is 6, plus 4 is 10. So the sample size is 11. Okay, great. Now, the next thing we want to look at is, what if we have this data set? Let's go ahead and calculate the mean and the median. So let's recall that the mean is just the average, which means we need to take the sum of all of these. So 1 plus 3 plus 9 plus 2 plus 5 plus 14 plus 12 divided by the total number that we have. So if you count this up, 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be this sum over 8. So I calculated this, and the number that you get is 6. And now let's calculate the median. So the median is what you get if you put all of the data points in order, and then after putting in order, you pick out the middle one. So let's go ahead and do that. So we have 1, 2, another 2. So I'm going to cross these out while I do them. So 1, 2, 2, and then the next number will be a 3. Great, and then the next number will be a 5, so we'll cross that out. The next number will be a 9, and then a 12, and then a 14. Okay, so notice we've crossed all the numbers up there out, and we've put them in order. And now what we can do is look at for which one is right in the middle. So we can do that maybe by crossing one out from either side until we get to the middle. So we'll cross that one with that one, that one with that one, that one with that one. But notice there is no middle. 3 and 5 are kind of both in the middle. So the rule is if there is no member that's right in the middle, you take their average. So that means the median in this case is 3 plus 5 over 2, which is going to be the number right between 3 and 5, which is obviously 4. So the median here is 4. Okay, I'll clean up the board and then we'll do some more. So the next example we want to look at has to do with the 5-number summary. So let's say we have this following data, which I've already put in order. So we've got 2, 2, 3, 4, 5, 5, 5, 6, 7, 9, 10, and 12. So let's count up how big our sample is. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So our sample size, which will be important as we move on, is 12. And then remember that the 5-number summary has obviously 5 parts. The first one is the minimum, and the last one is the maximum. So those are actually easy to calculate. So the minimum, well, that's going to be equal to 2. And then the next part of the 5-number summary is the first quartile. And the way to get that is to find the locator. So the locator for this first quartile is going to be given by the sample size. So that's going to be 12 over 4. And so it's over 4 because it's the first quartile. So we're taking a quarter of that. But that's going to be equal to 3. So that's the locator. But since that's a whole number, then the first quartile is going to be the average of the third data point and the fourth data point. So that's how you take the average of the third and the fourth data point. And well, what if it were not a whole number? Then you would just round it up and you would take that data point. So if we had gotten something like 3.2, then we round that up and it would have been the fourth data point. Okay, so let's go ahead and look at the third and the fourth data point. So 1, 2, 3, so the third data point is 3 and the fourth data point is 4. And so that's 3 plus 4 over 2. So here we get a 7 over 2, which is 3.5. Okay, so that's going to be the first quartile. Now the next thing that we need to do is find the median, okay? And we're going to find the median just like we did before. So we'll count back until we get to the middle. So notice we'll count one at a time on either side. So here's these two ends, and then we'll count in, actually here, in, here, and then here, 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 and notice there is no middle. These two guys share the middle, which means we need to take their average. So the median is going to be 5 plus 5 over 2, which is obviously going to be 5 itself. Okay, great. Now the third quartile is going to work pretty much the same as the first quartile, except our locator, instead of being 12 over 4, it's going to be 3 over 4 times 12. So notice that this is 1 over 4 times 12, or 0.25 times 12. So let's go ahead and calculate that. So it's 3 over 4 times 12, but notice that's equal to 9. And then since that's a whole number, then our third quartile is going to be the average of the 9th data point and the 10th data point. So in other words, it's going to be the 9th plus the 10th over 2. So let's calculate the 9th and the 10th, or count them out. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we've got 7 is the 9th, 9 is the 10th. So it's going to be 7 plus 9 over 2. The average of that is 8. So that's our third quartile. Then finally, we need the maximum, but the maximum is really easy to find. We just say it's going to be the number 12. Okay, so that means our 5-number summary will be given by these 5 numbers. So we have 2, 3.5, 5, 8, and 12. Okay, and now we can make something called a box plot with that, and we do that in the following way. So we're going to make a number line down here with all of the numbers between the minimum and the maximum. So we have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Like that. And now we'll graph each of these points above this number line. So 2 is going to go right up here above this point on the number line. So 3.5 will go right here. 5 is right up there above 5. And then 8 is going to be up here. And then finally 12 is going to be up here. Then we make a box starting at the first quartile, ending at the third quartile. So there's our box. And then we put a vertical line inside that box at the median. And then finally, we add these things which are called whiskers from the third quartile to the maximum and the first quartile to the minimum. So there's our box plot for this 5-number summary. So again, that's just a graphical way of seeing the 5-number summary. All right, I'll erase the board and then we've got one more example. So for our last example, we want to find the mean and the sample standard deviation for a data set. Okay, so let's say our data set is this one. It's got 3, 3, 6, 7, 8, 9, 9. So notice that our sample size, which is the number of data points, is going to be given by 1, 2, 3, 4, 5, 6, 7. Good. And then the mean, well, that's just the average, and often we use this letter mu to give us mean. Sometimes this letter x with a line over it gives us the mean, and so that's going to be equal to the sum of these. So 3 plus 3 plus 6 plus 7 plus 8 plus 9 plus 9 over the sample size, so over 7, like that. Okay, now you can add all those up, you get 45 over 7, and I'll just say that is approximately equal to 6.43. Okay, great. Now I'll let you guys look up in the textbook or somewhere else for the definition of the standard deviation. I'll just give you a nice simple way to calculate it. So a nice way to do it is by forming a chart. So let's do each data point one at a time. And so the leftmost column will be the data point that we're working with. And then maybe we'll call this data point xi. And then the middle column will be given by the deviation. And that'll be the deviation from the mean. So that'll be mu minus xi. Good. And then finally, the last one will be the square of that. So I'll just write that as mu minus xi squared. Okay, so we've got 7 data points to work with. So that means there's going to be 7 rows in this table. So we'll just do one at a time. So 3, 3, 6, 7, 8, 9, 9. Okay, so we've got something like that going on. Okay, and so now here we'll do the mean, which we calculated right here, minus this data point. So in other words, we'll do 6.43 minus 3. And then over here, we'll square that. So 6.43 minus 3 quantity squared. Okay, good. And then the next thing that we want to do is continue that down all of these columns. So here we'll have 6.43 minus 3, and then here we'll have this quantity, 6.43 minus 3 squared. Okay, and then here we're going to have a 6.43 minus 6, and then 6.43 minus 6 squared. And here we'll have 6.43 minus 7, and then 6.43 minus 7 squared. So the next thing that you want to do is add up everything that you get from all of these columns. So let's finish this off real quick. So this is 6.43 minus 8, and then this one will be 6.43 minus 8 quantity squared. Here we have 6.43 minus 9. 6.43 minus 9 quantity squared. Then finally 6.43 minus another 9. 6.43 minus another 9 squared. Okay, so the next thing that you want to do is take the sum of everything in this column. So this column that is furthest to the right, and I'll just say that here you get 31.714. So that's what you get when you add all of those up. And then finally, the standard deviation, which we all often write with this lowercase sigma. So that's going to be given by the square root of this number right here, 31.714, divided by the sample size minus 1. So that's going to be 7 minus 1. Okay. Good, and so I'll just say that this is approximately, if you plug it into a calculator or something, 2.57. So that's going to be the standard deviation in this case. All right, we're going to end the video here.